Welcome to 4.1 probability distribution functions for a discrete random variable. So basically we're just going to talk about like some of the notation, things that come in this section, what we're going to use from chapter 3, more specifically section 3.1 to kind of like set the stage for this chapter 4. So chapter 4 is going to take everything that we've learned about probabilities and then combine it all together with mean, variance, standard deviation. We'll revisit those topics back in chapter 2, and along with a new topic, the binomial distribution function, which provides using a calculator to find that. Will set the stage when we get to chapter 5 and 6. So chapter 4 is more specifically about discrete random variables, and so that went to a particular type of data that was numerical but also couldn't be separated. So those were basically whole number quantities that couldn't be divided, no decimals in these responses. So a lot of times they're asking, people like, how many movies did you watch? How many cup of coffees did you buy? Things like that. Here in the example here, we're going to look at some of the notation. We'll talk about random variable x, and that there's an uppercase and a lowercase indicated for it. The uppercase is the set itself, the set of all responses, and x would be one of those values in that set. Also, we're going to look at sample spaces. So as we talked about back in 3.1, it's important to develop and know what the sample space is before you get started. So this will be somewhat of a task on your part to put together all different outcomes, be it cards for the 52 card deck. In this case, 3 tosses of a coin, 2 tosses of a coin, could be 4 tosses of a coin, could be something like rolling of a die, then tossing a coin, things like that. So you need to develop the sample space first. In the preliminary examples, we'll do that for you, and then as you get going through the problem set, you'll need to do that on your own. Other thing too down here at the bottom, and then also talks about the definition, what a PDF is, and as we talked about that in 3.1, I did that there. And also down here at the bottom, some things I'm going to cover up there in the next problem is, as we go along, that there's no negative probabilities, that all probabilities are between 0 and 1 as a decimal, or between 0 and 100% as a percentage. And then the last part down there is that the sum of the probabilities is always equal to 1. And we verified that before when we looked at relative frequency. It's the same type of thing. So as we talked about relative frequency, that's going to kind of merge into this topic of 3.1. So with that, what I'm going to do is just an example illustrating that with this section. So let me go ahead and do that now. This next one's going to look at kind of setting the stage for the other problems. And the question is, you want to verify, is this a PDF? So here it is here. The following is a probability density function or distribution function. And the way that we know that is, in this case, we have all proper fractions, and that means that none they're not over the value of 1. They can be the number 1, very rare. I mean, you could have a probability that's 1 and 0, like either guaranteed or impossible. But nonetheless, if you have more than one, response rather than 2 responses, like yes or no, then it would have to be a case where probabilities like this, like a proper fraction, or again a decimal value or a fraction that's between is 0 and 1 in that case. So and the other thing down here to check is that there are no negatives. So not above 1, no negatives. And then when you're done with that, you need to verify down here that the total is 1. So you get 50 out of 50 when you add those all up, which is equal to 1, and you get 100%. So that's what we do to verify when you're asked to verify, is this probability distribution indeed a PDF? And so that will be the questions in the homework problem. It says to verify you have have a PDF. And so that's all you have to do is make sure that you don't have any negatives and nothing's above the value of 1. And then the last point down here is to make sure that the total of all the probabilities is equal to 1. And that will do it here for just a slight little brief introduction of 4.1 for the topics to come, which we'll be doing this more in detail and also leading into other parts of Chapter 4, which again will be taking the distribution, the PDF, and finding the mean, variance, and standard deviation, amongst other things too.